So guys, you can see that there are 4 counters now, exactly same as in the first video of this series. 4 counters using one variable. Now I show you what is happening on the micro C, and in the micro C, as you can see that we have the LCD initialized like in the previous video. We have 2 integer variables initialized, integer and a char. Then we have the LCD initialize command. Then we remove the cursor. Then we clear the screen. And then what we did is that we converted the integer to a string to display it on the LCD. Then we move the cursor. Now we are going to use the cursor command. So we display the LCD out CP, start writing from the first row. Now this starts from the first row, and wherever this ends, it will start from the same row, because we have not given any syntactic that which row it goes. So it will continue where the cursor was last. Then we go to the second row and we write the third counter, and then from where the third counter ends, it automatically starts writing from that point. Now again the loop repeats, and again we move on to the first row. So this simple programming gives us this result. So guys, this is it. Hello guys, welcome to learning microcontrollers. In this video I will show you how you can interface an LM016 16x2 LCD with a PIC microcontroller, and this is the second video of this series. And in this video I will show you another technique, that how you can run 4 counters on a 116x2 LCD using a single variable. So this will be the second method. The previous video, I used the LCD out command. In this method we will use the cursor. To move the data here and there. So let's get started. Let me first show you how you can connect the LCD with the PIC, and then we will fetch the files from the previous video, and then we will edit them for this technique. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This over here is a 16x2 JHD LCD, also known as LM016. And guys, to interface this with the PIC, we will need a 3-pin 10 kilo ohm variable resistor. This will be used to adjust the contrast of the LCD. So let's label it as labeled on the body of this potentiometer as well. It has 3 pins, 1, 2 and 3. And for the LCD, it has 16 pins from 1 to 16 from left to right if you hold it like this. Let's do the connections. So pin number 1 and 5 of the LCD, you common them, then you send it to the pin number 1 of the potentiometer, and then you send it to the common ground. In this way your LCD gets a ground and your potentiometer gets a ground. Now guys, pin number 3 is the adjustable contrast pin of the LCD. You will connect it to the adjustable pin of your potentiometer, that is pin number 2. Now guys, pin number 2 of your LCD is the VDD pin. From here you give 5 volt to the LCD. You will connect it to the pin number 3 of your potentiometer, and then you send it to the VCC pin of your PIC microcontroller like this. In this way your LCD gets the 5 volt and your potentiometer gets the 5 volt. Now guys, pin number 4 of your LCD is the RS pin, and for this pin you can use any available digital input output pin of the PIC. I am going to use the pin number C0, that is pin number 15. For pin number 6, that is enable pin, I am going to use C1. For pin number D4, data pin 4, that is pin number 11 of the LCD, I am going to use C2. For data pin 5, I am going to use D2. For data pin 6, I am going to use D3. For data pin 7, I am going to use C4 like this. Now guys, here these 2 pins left at the right side are 15 and 16 of the LCD. They are for the backlight. You will only connect them if your LCD do have a backlight, and if your LCD don't have a backlight, then you don't need to connect them at all. And my LCD do have a backlight, so 15 is the 5 volt pin for the backlight, and 16 is for the ground pin. Even if you don't connect pin number 15 and 16, if still your LCD will work, but it will be very difficult to see. So with the backlight it becomes very easy to see. Now these 4 pins 7, 8, 9, 10, they are for the 8-bit mode, while we are connecting this LCD in the 4-bit mode. So guys, in this way our connections are completed. So let's fetch the Proteus and the micro C files from my previous video. So guys, this on my channel, you can go to my channel. I will share the link as well. Here you have this video of this series, the first video. In this I use like LCD run 4 counters using one variable with PIC16F877A method 1 LCD out command. Now we will just fetch the files from here. Okay, just go to the description of this video, and in the description you have this link. Go down there, link to micro C for files and Proteus files download. Open this Google Drive link. This will lead you to this page. Here you have both the files, the micro C file and the Proteus file as well. So download both. First download the micro C files. Okay, it is downloading, zipping. See, okay, it's downloaded. Now download the Proteus file as well. We will need both of these files. Okay, let it download. Okay, both are downloaded. Now go to the folder where you have downloaded them. Copy both. Just paste it to a suitable place. I paste it here in a new folder like this, and now extract both files. Okay, I think I have to do it manually. Okay, bring it out. Also the Proteus file as well. Bring out both the files like this. Now this is for the micro C file and this is for the Proteus file. Now go to the micro C, whichever version you have. I am going to use this version 7.6.0 here. Just click on File, Open. Go to the folder where you have your file generated. Okay, just go to that folder. I have it in Drive C, and new folder. I made a new folder like this, and here, okay, this is not the new folder. Okay, here we go, micro C for PIC file. See, only this file, the C file. You just double click on it and this will open up here like this. Now this is great. Now we also open the Proteus file as well. The one we downloaded, just turn on the Proteus, whichever version you have. Okay guys, the Proteus has turned on. I just click on this schematic capture and it's Proteus 8 professional demonstration vision. Okay, click on File, Open. Now go to the folder we have where you just have downloaded that file from my previous video. I have downloaded here Proteus files. This is the file. Okay, here we go. It's working. Now go back to the micro C. So we just continue this programming here. Just first of all, you make a new file. Don't try to edit this because debugger will not work. Click on File, New Project. Here you get to this window known as New Project Wizard. Click on Next. Write the name of the project. I write, okay, method 2, 4 variables, sorry, 4 counters, 1 variable, tutorial, learning microcontrollers. Okay, any name you can write. Select the path where you want to create the hex files. Select the microcontroller. I am going to use the PIC16F877A. Select the crystal connected to pin number 13 and 14 pin of your PIC. Mine is 20 megahertz like this. Click on Next and finish. Now guys, first of all, save your work. Press Ctrl S. Now go to the file you just opened. Copy all of it. Ctrl A, Ctrl C, and then paste it here like this. Now guys, first of all, go to the right. To initialize the libraries, we are going to use the conversion library because we cannot display integers, hex or decimals directly on the LCD. We need to convert them to a string. So this library does that. And for the LCD library, check mark this as well because we are going to use this library. Now see what is happening here is that we had turned off the cursor. So now in this video, I will turn on the cursor. We will use the cursor now like this. And guys, above this we have initialized the LCD. Okay, that's great. If you want to see how I initialize this, just go to that video. I will share the link to that video in the description. And guys, then we took an variable integer inc which will increment, and then guys we took an increment 1 which is a char because we cannot display this directly on the LCD. We will convert them to a string using conversion library, and then we will store this in this array of char. An array of char is a string, so this is a string having 11 characters. Then we initialize the LCD, that's great. Then we clear the LCD for first run. Then we made the increment 0 by default, that wherever the code starts, increment is 0. Now guys, here we are converting increment, whatever the increment value is, to a string to display it on the LCD. Then we are displaying this string on the LCD. See, LCD out, start writing from the first row, first column. Now we are not going to use this command. We will use another command. Go to the right. Here you have this command LCD out CP. Now we are going to use the cursor to display the variables. See, LCD out CP, you copy this command, you paste it instead of this. Now LCD out CP, what it should out? This increment 1, pasted inside it. Now whatever is in the increment 1 will be displayed on the screen, but from where? We should start, we have to write this at the first row and first column. So how the microcontroller will note that start writing from the first row and first column? For that purpose, go to the right in the LCD CMD library, double click on it. Here you have this command LCD CMD LCD clear. This command clears the screen, but you paste it here, we will need the syntax. Now this is the syntax of LCD CMD command, and remove the clear command like this. Now go back to the LCD CMD library. There is a available command table at the bottom. See, now LCD first row, this command, move cursor to the first row, copy this. Now we will start writing from the first row. Whatever is in this will be start writing from the first row. Now for the second one, it will be written at first row and 8th column. Now you copy this and just replace this with this command. Because the great thing about using the CP command is that, the cursor command is that, it will not start writing from the first row until you do not ask it to start writing from the first row. It will continue to write wherever this one ends. Suppose it took like 6 digits on the screen to write this, and after 6 digit, it will automatically continue from that point onward. So it will be automatically written next to it, the second counter. Now for the third counter, it is going to the second row. It will start writing from the second row and first column, while our cursor is on the first row. So what we do is that, go to the right again. Now bring the cursor to the second row, copy this syntax LCD CMD, paste it above this like this. Now inside it, remove the LCD clear. We do not need to clear the screen, we just need to move the cursor to the second row. Go to the table. Here you have this command LCD second row, and this is the command here. Move the cursor to the second row. You copy it, paste it inside the brackets like this. Now the cursor will be moved to the second row, and from the second row, first column, it will start writing this. And next, the fourth counter is on the second row, 8th column. Okay, I think we made a mistake here. We need to paste it here, sorry. Now here it will start writing. This is the first row, first column, then it will start on the first row, whatever the space is left, and then it will start from the second row, first column, and then again write this here. Now this is our third counter, starting from the second row, first column. Now this is our fourth counter. Just copy this and paste it here, because cursor is already on the second row like this. See, it is already on the second row. Now once it's done, it will write from the second row, first column, and from where it ends, it will write the second value over there. Now the loop repeats. Again, it will move the cursor to the first row by using this command. So what we do is that we simply build the code, check for errors. So we have an error at which point, okay, we have accidentally added this, remove it, again build it. Okay, it's built successfully. Now let's go to the Proteus. Okay, this over here is the Proteus. Double click on this PIC16F877A. Crystal is already 20 megahertz. Go to the file. Now go to the folder where you have created your hex files. Okay, here. Okay, there I go. This is the file. I click on OK and start the simulation. See, that is how beautifully it is writing the data. See that? This is the first row and this is the second row. So total 4 counters using one variable. Now this time we are using a cursor command to write it down. Now what I do is that this cursor is looking odd. We remove the cursor as well. So go to your micro C. First stop the simulation and go to the micro C. Now what you do is that we had commented this command cursor, LCD cursor off. Just uncomment them. Now this command will remove the cursor. Now build this. Go to the Proteus and again play the simulation. See, now we have no cursor. See, it is exactly working like in the previous video. So guys, this is it. I hope you guys learned something from this video. If you have any questions, you can ask me in the comment, and it is very happy for me to hear whenever you learn something from my video. So please do tell me in the comment. So guys, we'll see you in the next video. Goodbye until then.